Hello, I'm Steve Buck, Chair of the Department of Psychology here at the University of Washington. The lecture you're about to see is part of our annual Alan Edwards Psychology Lecture Series. Professor Edwards was affiliated with the Department of Psychology for half a century until his death in 1994. He was an outstanding teacher, researcher, and writer who introduced new statistical techniques that are credited with changing the way modern psychological research is conducted. Alan also permanently enhanced the intellectual climate of UW Psychology by endowing the Alan Edwards Lectureship, which since 1999 has brought an impressive list of renowned psychologists to the UW campus to interact with faculty and students. Now, the annual Alan Edwards Psychology Lecture Series presents the excitement of psychological research and its tangible benefits to both local and national audiences. The lecture you're about to watch is one of a pair given back-to-back that matched a UW Psychology faculty member with a visiting researcher to talk about a topic of great public and scientific interest. Good evening. I'm Steve Buck, Chair of the Department of Psychology here at the University of Washington. I want to welcome you to this evening's continuation of the Alan Edwards Psychology Lecture Series. This series is presented by the College of Arts and Sciences and the University of Washington Alumni Association and funded by a generous endowment from Alan L. Edwards. The topics in this series illustrate how psychological research serves humanity. The University of Washington receives more research support money than any other public university in the nation. The Department of Psychology alone receives almost $10 million annually in research funding that helps us advance our knowledge of basic science, directly serves people in our community and around the globe, and helps train our undergraduate and graduate students. Tonight's lecture addresses symbolic understanding in infants and young children, challenges and benefits. Our next speaker is Dr. Stephanie Carlson. Dr. Carlson is an associate professor in the Department of Psychology here at the University of Washington. She directs research on young children's self-control, pretend play, and social awareness at the Child Developmental Lab. She is particularly interested in how these skills develop in early childhood, how they're interrelated, and how they're influenced by culture. Dr. Carlson's research is funded by the National Institute of Child Health and Human Development. She serves as consulting editor of the journal Developmental Psychology and on the board of directors of the Jean Piaget Society. Her research on imaginary companions, symbolism, and self-control processes has been featured in a long list of local and national interviews for newspapers, magazines, radio, and television. Dr. Carlson has played a key role in designing our undergraduate curriculum in developmental psychology, and among other distinctions, she was selected as a favorite professor nominee by the UW Alumni Association class of 2005. Please help me welcome Dr. Stephanie Carlson.
Thank you, Steve, for that introduction. It's a great honor for me to be here to speak to you tonight about my research and particularly to share the podium with Dr. Judy Deloche, whose research has been very inspirational for my own. I wanted to give you an overview of my research program just very briefly so you can see what kinds of questions we're investigating in our lab here at the University of Washington. And then I'd like to propose to you a symbolic distancing hypothesis that we're investigating. And it relates very closely to what Dr. Deloche was talking about, the achievements that infants and young children have in symbolic understanding, how that can then be turned to good use for other aspects of cognitive development, particularly the development of self-control. And I'll present to you briefly 4 pieces of evidence that we have in favor of this hypothesis: observational research, experimental research, research on individual differences, and research on bilingualism. And I'll conclude with summary and future directions. Before I go on, I'd like to acknowledge the families participating in research, many who might be here tonight, families who have brought their children in. We couldn't do it without you, and I really appreciate it. The funding agency of NICHD, the Department of Psychology support, the UW Institute for Learning and Brain Sciences, and my colleague and collaborator there, Andrew Meltzoff, the Royalty Research Fund of the University of Washington, graduate students Danielle Beck and Angela Davis-Unger, Catherine Schaefer, and many, many undergraduate students. We, in general, look at representational development, particularly interested in how increasingly complex representations of the self and the world that occur in the first 5 or 6 years of life or so enable children to step back and reflect upon their own behaviors and their own actions and thoughts. How it is that children move from being rather stimulus-bound to having conscious control over their thoughts, actions, and emotions. And this development of representational skills is important for problem solving in multiple domains. We're interested in how representation affects 3 areas of development: the representation of mind and mental states in theory of mind development, representation of reality, as in imagination and pretense, how children deliberately play around with these representations of reality, and representation of one's own thoughts and actions. And this is seen in the development of self-control, also referred to as executive function in the developmental psychology literature. Dr. Deloach referred to the development of symbolic understanding, and I wanted to describe this in a way that's a hierarchical model in which children in the first few years of life move from being rather stimulus-bound at the first level, having no reflection on their own representations of the world, to being able to hold symbols in mind and substitute them for reality. But still at the second level of development, say the latter half of the first year of life, there's no reflection on the relation between symbols and reference. Then there's a major achievement at level 3, occurring around 2.5 to 3 years of age, when children begin to use symbols as symbols and reflect on the symbol-referent relation. And that's seen in this drastic increase in pretend play, and also children's ability to now understand scale models, as Dr. Deloach talked about. There are later developments in the complexity, further understanding of the nature and quality of symbol-referent relations, such as understanding irony and sarcasm, that occur well into the elementary school years. The symbolic distancing idea is that symbols produce psychological distance, not a physical distance necessarily, but at least a psychological or mental one. And these are behaviors or events that separate the child cognitively from the immediate behavioral environment. And under this hypothesis, what symbols do is help us to achieve some modicum of control over our thoughts and actions by, in a sense, putting a screen between, say, you and your automatic behavior, between a stimulus and an automatic response. And this is an age-old idea, but it's only recently begun to be tested systematically in young children. So you have a stimulus and response, some kind of a knee-jerk reaction, such as you see a bowl of goldfish and you reach for it and you grab it. What symbols can do, if you were to have, say, a symbol for the goldfish, that might enable some reflection, the stepping back, holding off, and taking a more considered approach to the goldfish, and maybe not grabbing at it or taking less. So under this idea, symbolic distancing is instrumental in allowing for representation and conscious control of one's own thoughts and actions. In other words, it's instrumental for self-control. The first set of studies that I want to tell you about to investigate the symbolic distancing idea is the hypothesis that, observation studies looking at the hypothesis that we should see increases in spontaneous symbolic strategies for problem solving with age. So in other words, what do well-regulated children do in situations demanding self-control? Do they spontaneously employ symbolic strategies and how does it change with age. So remember that once children are 3 to 4 years old, they've achieved this dual representation ability that Dr. Deloche referred to. They've achieved symbolic understanding in its basic form. How can they then use those strategies, use symbols deliberately in the service of a goal? So I want to present to you a measure of delay of gratification that we use to test this idea. And the delay of gratification paradigm was originally developed by Walter Mischel and colleagues at Columbia University in the early 1970s, and it's proven to be a very long-lived task that helps us learn a lot about development still. So in this task, children are presented with 2 trays of treats. This child has Fruit Loops. He's given a choice between 2 Fruit Loops in one plate and 10 in the other, and asked which one he prefers. He prefers the larger amount. Then we say, okay, well, how about you stay in your seat and wait until I come back by myself, and then you can have this large pile of treats. But if you don't want to wait, then you can ring this bell, and the bell will bring me back. It's the bring me back bell. And I'll come back, but then you can only have the small pile of treats, okay? And so we make sure that children understand the game, and then the researcher leaves the room, and the child's being observed. The child's alone in the room, but being observed by the camera. And so here's a 4.5-year-old who is deciding whether or not he wants to endure this delay. They don't know how long the delay will be. It could be all the way up to 15 minutes. So he rings the bell. We didn't have audio on that, but he rings the bell 34 seconds into the delay. So that's one way to, in a sense, fail to delay gratification. Other children attempt to be more subtle in the way that they express their temptation. So this child is faced again here with Fruit Loops, and she's 3.5, and here's what she does about 18 seconds, I should say, into the delay.
Hey, Lena, you did a great job waiting.
So it's pretty sophisticated for a 3.5-year-old, but technically she failed. So if they eat the treats or ring the bell, then we end the procedure, and their score is not quite having that delayability in place. But many children do delay, even up to 15 minutes. And what we did was to examine what is it that children do, what kinds of spontaneous strategies do they come up with to help them delay gratification. And so this is a study that Danielle Beck and I did with 3 to 4-year-olds, and it was a delay of gratification task that I just showed you for 5 minutes, up to 5 minutes. And we categorized children's spontaneous strategies according to whether they were symbolic. So for example, using rule reminders or goal reminders. So for example, one child who had decided that she wanted to wait for the large amount looked at the large amount, nodded her head yes, and went as if to hug the large amount of treats, and then she looked at the smaller amount, shook her head vigorously no, and made a big X across it. So it's as if to kind of keep in mind the goal here is to wait for the big reward. They sometimes use pretense strategies, such as pretending to feed an imaginary friend the treats over and over again during the delay. And many children will use talking or singing during the delay. And then we contrasted that with non-symbolic strategies, such as line of sight, so turning around in one's chair, anything so as not to have to look at the treats anymore. Interacting with a parent who was across a one-way mirror, kind of attempting to engage the parent. And physical restraint, such as moving the treats farther away from them on the table or moving the bell away, or sometimes sitting on their hands. This is an example of a singing strategy that a child uses in a similar task, waiting for 5 minutes before he gets to open the present that's inside that box. And this is a 5-year-old boy. I want to make sure we have the audio working this time. Okay.
I'm waiting, I'm waiting, I'm waiting, waiting, waiting. Come back, waiting, 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 waiting. I'm waiting, I'm waiting, waiting, waiting. Waiting, waiting, waiting. Waiting, waiting, waiting. I'm waiting, 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 waiting.
So for the entire 5 minutes, he sings, I'm waiting, I'm waiting, I'm waiting. So it's a catchy refrain. So what we see are interesting changes from younger to older kids in the 3 to 4 year age range, where line of sight strategies are significantly decreasing. It's a relatively non-symbolic strategy, whereas the symbolic strategy of talking and singing is significantly increasing across this age range. No change in interaction with the parent, a significant increase in pretense, and a significant increase in rule reminders, and at the same time a significant decrease in no use of strategies. So children become more likely to use a strategy, and by and large, what they're removing are these line of sight strategies and adding a more sophisticated symbolic strategy of talking, self-speech, private speech, singing. Strategies were related to age, as I just showed you, also to verbal ability. So we do administer verbal ability assessments in just about every study that I'll tell you about today. It was predictive of their delay time. So using strategies did in fact help children delay gratification in this task. And it was also related to children's performance on other self-control tasks. So far, we've shown that children's own strategies for problems or situations requiring self-control become more symbolic with age and increased verbal ability. In contrast, non-symbolic strategies either decreased or showed no change. The second way of looking at the symbolic distancing idea is through experimental studies. And the hypothesis was that manipulating symbolic distancing should have a systematic effect on problem solving, so that responses are made in light of the symbol rather than the stimulus. In other words, if we design a self-control task that is normally difficult for preschoolers, what happens when we make it more symbolic? Does that seem to help? And we designed the less is more task for children to examine this idea. In the less is more task, children are presented with these 2 trays of treats, and these are Skittles, 2 versus 5 Skittles. And again, we say, which one do you like better? And 3 and 4-year-olds like the larger amount. Then we say, okay, in this game, whichever one you point to, whichever tray you point to, those treats are going to go to Chris. And Chris is this monkey puppet. And children are told that he's naughty and he doesn't share. Okay, so whichever tray you point to, those treats are going to go to Chris, and they'll go into his cup, and you'll get the other treats. They'll go into your cup. So what children need to infer, the next sort of mental leap that they need to make to do well in this task, to maximize the rewards for themselves, is to figure out that, aha, if I point to 2 treats, those get given away, and then I get 5 treats. Okay? And so we call it less is more. Children choose which treat they like best out of our snack selection to make sure that they're motivated. They make a size preference, usually choosing the larger amount. We explain the rules and do a demonstration and a practice trial. And then we do a verbal rule check with children. And we say, okay, so in this game, when you point to a tray, who gets those treats? Just want to make sure that we're clear before we play the game, that they understand that they're going to be given away. Then we do 16 test trials, and we ask children again what the rule was at the end of the game. This task is relatively difficult for 3-year-olds. What they need to do is point to the smaller amount in order to get the larger amount. But their tendency, due to poor inhibitory control, is to keep pointing to the larger amount. So I'm going to show you what this child does.
Point to a box. Point to a box. One, two, a box. One, two, a box.
Okay, so he kind of makes as if to grab for himself the larger amount each time. And in fact, it is quite difficult. This is the percentage of 3-year-olds versus 4-year-olds who pass the less is more task. And only about a quarter of the 3-year-olds were doing well when they're faced with these real treats. So we then examined this idea of symbolic distancing in the context of the less is more task and asked whether it would make a difference if we could help children, give them a leg up by helping them substitute in their mind these real treats, here 2 versus 5 jelly beans, if we could kind of overwrite that representation with a symbolic one for a smaller amount and a larger amount. So for example, telling them that the mouse is the same as just a few treats and an elephant is the same as a lot of treats. So to examine this experimentally, we randomly assigned children into one of these 4 groups. So one group of children participated in the real treat condition, just like I had shown you earlier, with these jelly beans. Another group was trained that with these rocks, okay, and told that every rock is the same as one treat. So 2 rocks versus 5 rocks. Another group was introduced to these arrays of dots that you see in the lower left-hand corner, and trained that the smaller array of dots, fewer dots means just a few treats, and a lot of dots means a lot of treats. And in the lower right-hand corner, the mouse and elephant that I described to you earlier, and they were trained using stuffed animals, a small mouse and a large elephant, and trained that mice are tiny and they have tiny tummies, so that means just a few treats. But an elephant is big and they have big tummies, so that means a lot of treats. Then in all cases, in all conditions, children would make a selection to one of these possibilities on top of these wells. They'd make a selection, and then the researcher would remove real treats from underneath the wells. So in the well underneath the mouse, there were 2 real treats that got distributed on each trial, and underneath the elephant were 5 real treats. So for example, to maximize the rewards, kids would have to figure out that they should be pointing to the mouse in order to get the larger amount of treats. Okay. And this is the effect of symbols on the less is more task with 3-year-olds. So we didn't even test 4-year-olds because they were already doing quite well. And recall that the 3-year-olds under the real treat condition, only about a quarter of them were passing. Well, again, only about a quarter of them passed the task with real treats. Children in the rocks condition did a little bit better, but not significantly so. And there was still that kind of one-to-one correspondence between the jelly beans and the rocks. Children in the dots condition did much better and were above chance. And here we've kind of broken that one-to-one correspondence, but there's still this obvious difference in the amount, in the numerosity between the 2 choices. And the children in the mouse-elephant, the most abstract condition, performed best of all. In fact, these 3-year-olds in the mouse-elephant condition performed identically to how 4-year-olds had performed with real treats. So in other words, by facilitating, by suggesting the use of symbols, we were able to show that 3-year-olds could perform as if they were 1 year older. And performance improved significantly as a function of the degree of symbolic distancing. So human children are not the only ones who seem to be able to utilize symbols in this way to control their behavior. And Sarah Boysen and colleagues developed this task that we then adapted for children. And when they used the task, they presented chimpanzees with either candy across trials. So every time the chimp would point to an amount of candy, that amount would be given away, and the chimp would get the non-selected amount. Just like in the less is more task. But these chimps are special, hand-reared chimps who are also well-trained in understanding numerals. So they're trained to recognize the numeral 5 and the numeral 2, and they know that 5 is larger than 2. Yet, when the researcher presented the chimpanzees with a numeral 2 versus a numeral 5, they quickly learned that if they pointed to the 2, they ended up getting a larger amount of treats. And the performance is actually nearly identical to how 3-year-olds performed in our study with real treats versus our most abstract condition. So there could be some interpretation difficulties, though, that with this work, so that maybe children and chimps view it as a completely different task when you're dealing with symbols, and not really linking up in their minds that, oh, this stands for these jelly beans. Maybe not really working for the jelly beans after all. Maybe the symbolic stimuli simply redirected their attention, but would not transfer to the real scenario. So that has to be sort of the litmus test of this hypothesis, that they have to be able to transfer this knowledge from the symbolic situation into the real situation to make a real difference in their actual problem-solving behavior. So to test this idea, we looked at 3.5-year-olds who were assigned to get the real treat condition first, followed by symbols, or vice versa, getting symbols first, followed by real treat. And so that symbol real condition was really the critical test. Could they, if exposed to symbols first, use that information to then perform better than they normally would have with real treats? And what we see is that when kids get the real treat followed by the symbol, their performance jumps up. And that's not surprising because symbols are easier and there's potentially some learning going on. Importantly, when they get symbols first, their performance also then goes up significantly, even when faced with real treats. By comparison, the real group, who only was exposed to real treats, 3-year-olds do not typically show learning across trials in that situation. So learning, in this case, in itself, is an interesting finding. So another way of saying this is that in the real condition, it mattered whether you were exposed to symbols first or not, whereas it didn't matter the order that you had received the symbol condition. So it suggests that 3-year-old children are able to capitalize on symbols in this way. And I want to give you an example of how several of the children in our study made comments. They had been exposed to the symbols first and then were given the real treats. And they made comments suggesting that they were directly importing their mapping, their representation from the symbol case into the real case to help them improve their performance. So this first child, it's just very brief, and he says, he's looking at the real chocolate chips, and he says, is that the mouse's ones? And then the second child that I'll show you, he's performing well with these real chocolate chips, and he says, how about I can keep the elephant's chocolate chips and give him the mouse's chocolate chips?
Is this the mouse one?
Point to a box. Point to a box. Okay.
Then how about I can get the elephant chocolate chip and Chris can get the mouse's chocolate chip.
Okay.
Okay, so in both cases, there's no more mouse or elephant present at all. Children are directly importing that mapping. So what we learned from the experimental studies is that less is more is a valid assessment of changes in self-control from 3 to 4 years. That experimental substitution of symbols for the real stimuli improved performance in 3-year-olds, and that the effect increased as a function of symbolic distancing. The effect also generalized to better performance in a real context in 3-year-old children. But interestingly, this is not the case in chimpanzees. So again, looking at some of Sarah Boysen's research, what she finds when she does this, where the same chimps are exposed to either real treats or to numerals, the symbol for the quantity, when they're faced with numerals, they do well, and then as soon as they're presented again with real food, their performance drops down. Back up again, this is across 8 sessions, back up again as soon as numerals are introduced, back down again for real the real deal. And we haven't tested 3-year-old children on this many sessions, but what I would predict is that once they've had exposure to symbols, that their performance, even on the real, in the real situation, will stay at a high level. So as Dr. Deloach alluded to, this could be a uniquely human ability to, it's not necessarily to represent things symbolically. That is the cross-species ability, but to capitalize on that in the service of a goal, a problem-solving goal, is something that might be. The third hypothesis that we wanted to look at is, okay, so we know that children are spontaneously employing these strategies more and more with age. If we help them out a little bit with experimental manipulations, they do better. What about naturally occurring individual differences? We see huge individual differences, even within the preschool period, in how prone children are to engage in pretend play, how much they engage in pretend play, whether they have imaginary companions, and whether they like to play with a partner or whether they like to play on their own. And at the same time, we see huge individual differences, even though there's big development taking place, huge individual differences in self-control in this period as well. So the question is, at a given age and verbal ability level, are children who engage in more advanced pretend play also better at self-control? Before we go on with the study, I want to just point out to you the paradox here. When we think about pretend play, we think that it's completely uninhibited behavior. That's sort of the point of pretend play, is that anything goes. But the paradox of pretend play is that, in fact, it is regulated behavior, quite well-regulated behavior. So in order to pretend, there's a sort of basic requirement of inhibition of reality. So to pretend that a broomstick is a horse, you have to, at a minimum, be able to suppress your representation of it as a broom and everything that comes to mind when you think about the function of brooms. You also have to be able to flexibly manipulate these dual representations. So for example, being able to step in and step back out of pretend play, or to view one and the same object as both a pretend object that you can manipulate in any way you want, and as an object, a real object in its own right that has its own affordances and own functions. And lastly, you have to keep tabs on who's who. In a social pretend play situation, there's a lot of regulation and monitoring that goes on when kids are trying to remember who's being the mom, who's being the dad. And if anybody violates these things, it's a real problem in a pretend play situation. So if a child suddenly switches up the role and starts becoming the mom when they're supposed to be the baby, that's going to get a pretty big reaction from a play partner. Similarly, if you violate a pretend representation, so for example, if you're pretending to eat mud pie and one child really bites into the mud, you can imagine the play partner's reaction. The pretense breaks down and suddenly the whole situation is not very well regulated. So to examine this correlation, this hypothesized correlation, we tested 3- and 4-year-old children on self-control tasks and pretend play tasks. And the pretense measures included this ability to hold dual representations, to view something as both an object in its own right and as a pretend thing. And we looked at social pretend play in a lab situation and non-social pretend play, such as solitary free play. And in many of the studies that I'm telling you about, we control for verbal ability and memory span because these abilities are also related to the constructs of interest, to both self-control and to pretend play. So I'm going to give you an example of a social pretend play task that we use where the researcher and the child are going on a picnic. And the picnic takes place all around the room, and they have to get to the picnic site, and it's quite a journey. It's all about the journey. And there are many obstacles, and what we're looking to see is when the researcher, say, she initiates a pretend representation. So for example, she'll pick up a broomstick and pretend that it's a walking stick. There's a child-sized broom in the corner, and we look to see if the child also picks up the broom and pretends that it's a walking stick. So imitation of what the researcher is doing in this pretend game. And then also looking for initiation. Do children initiate novel pretend ideas that are theme relevant? Okay, are they adding anything to the pretend play? And here's an example of a 4-year-old boy going on the picnic, and we started to call him MacGyver because he had a solution for everything in his pocket. So they're going on the picnic, and they have these obstacles, and he says, "I have some engines in my pocket. I think we can do this because I have some engines in my pocket." So I want to show you what he says.
Paul, you know what? I think I see snow on it.
You see some snow on it?
Yeah.
Yeah?
I have some engines that can melt it.
Can melt the snow?
Yeah.
Okay.
I have them in my pocket.
Okay. I'm going to start walking up.
Go.
This mountain is so steep. We're almost to the top.
I think I can do it.
You think you can
I
make it?
think if we just I have some engine in my pocket that can maybe get us up there faster.
Okay.
Here, cat.
Got it. All right.
Okay. So there's a lot going on there, both in terms of imitation and initiation of theme-relevant pretense. So here's where the regulation comes in addition, because some kids can be adding a lot of imaginativeness to a situation, not necessarily here, but with their own friends in a pretend play situation. But if it's not theme-relevant, it doesn't go very far. And so I think that's an important piece. And here's what we find, these fairly strong correlations between individual differences in preschooler self-control and their pretend play. And what I'm showing in the yellow bars are the raw correlation, and then when we control for factors such as age, sex, verbal ability, memory span, then the relations are reduced, but still significant for 2 of the aspects of pretend play. So this representational aspect, understanding dual representations, is strongly related to self-control. And even this online, more dynamic situation in the lab, such as the picnic task that I showed you, individual differences there were related to self-control. So individual differences in symbolic play and self-control are related in support of this symbolic distancing idea that individual differences in these 2 constructs tend to co-occur. And it's highly robust in terms of understanding the representational nature of pretense, but also significant, and there was an independent contribution of social pretense with a partner. And I think this is really important in terms of thinking about what goes on with peers. In a preschool situation, most of their activity is surrounding pretend play together, most of their joint activity. And if one partner is not so good at regulating that, it could have serious consequences for, say, peer acceptance in preschool. Okay, the last piece of evidence that I want to present in support of the symbolic distancing idea has to do with context effects. So we were talking just now about individual differences in symbolism. Well, what about contextual or group differences in symbolism, in exposure to multiple symbol systems? And this occurs naturally in the case of bilingualism. So the hypothesis is that group differences in exposure to multiple symbol systems should be related to self-control. At a given age and verbal ability level, are bilingual children more advanced in self-control than monolingual children? The hypothesis stems from the idea that bilinguals engage in a lot of code switching. So continually and quite flexibly, impressively, switching between these language systems, these different codes. And what they're doing in the process is actively selecting the relevant language, say if they're talking to Spanish-speaking mom, and suppressing or inhibiting the non-relevant language as the situation calls for it. So this constant practice ought to hone these cognitive flexibility skills, which in turn might help them in self-control situations. There is some prior evidence for this research, for this idea, research by Bialystok and colleagues in Chinese-English bilingual children. But the problem is with this research is that we know that Chinese monolingual children also do better than North American children in self-control tasks. So to test this idea further, Andrew Meltzoff and I tested a group of Spanish-English bilingual children. And this is the, Spanish-English is really relevant because it's the fastest growing bilingual population in the United States. And we compared 3 groups of children: native bilinguals, monolingual English-speaking children attending traditional kindergartens, and monolingual English speakers enrolled in a language immersion kindergarten, where half of their instruction, 3 hours each day, was in Spanish and half in English. They were given a battery of self-control tasks, including selective attention and delay of gratification tasks, like the one I showed you with the bell and the treats. And again, we controlled for verbal ability. What we found was that in these kindergarten children, the native bilinguals performed significantly better on the self-control composite battery than did the traditional kindergarten control kids and the early immersion children enrolled in early immersion school. We further found that it wasn't necessarily across the board that the bilingual children performed better. Instead, there was a specific effect, a specific advantage, relative advantage in terms of the selective attention ability. They did not perform significantly better on delay of gratification. So it suggests that there could be something about this code switching idea and selecting the relevant language, suppressing the non-relevant language that seems to be the mechanism. So it's a replication in Spanish-English low-income sample of relatively advanced self-control skills, specific to selective attention versus delay. And there was no effect of early immersion, but it could be that it wasn't a long enough duration in the early immersion program. Or it could be that it is something that's specific to native language acquisition, and that late exposure, no matter how intense it is, would not confer the same benefits. There are several interpretations of these findings. As I mentioned, it could be this inhibitory control, selective attention idea. It could also be that bilingual children engage in a lot more self-speech. And so they have this reflective capacity that gets practiced because they're engaging in private speech to kind of tell themselves about what's appropriate in a given situation. And then another interpretation is that it might not be the bilingualism per se or language per se, but that they're also bicultural. So they engage in a lot of switching, not just between languages, but between worlds, sometimes between home life and school life, for example. And that this is, in fact, what could be contributing to this greater flexibility that shows up in our self-control tasks. And we just don't know yet about which of these interpretations is correct. Okay. So I've told you about this idea that once children have these basic requirements of understanding symbols, understanding dual representations, and Dr. Deloche talked about how inhibitory control could be important in helping them get there, right? Once they're there, in turn, my argument is that symbols and symbolic understanding helps children further develop their inhibitory control or self-control skills. So it kind of happens on both sides of this preschool divide. We saw spontaneous symbolic strategies for self-control increase in the preschool years. Symbols facilitate performance on a self-control problem and transfer to the real situation. We saw that in the less is more task. What we don't know is how long-lasting those effects are if we were to bring children back much later. There are individual differences in preschoolers' pretense skills that are significantly related to their self-control. And I mentioned that one future direction there would be to look at how this is playing out, so to speak, in a preschool social setting where kids who are better or worse at regulating pretend play might start to have some peer problems. And lastly, we showed that group differences in experience with language are related to performance on self-control tasks. And we need to do further research to investigate the source of those differences. Thank you very much for your attention.
Thank you, Dr. Carlson. We can take a few questions, so if you can work your way to the aisles to the microphones, we can all hear your question. I have one. The differences you showed for the native bilingual Spanish-English speakers versus the immersion speakers is interesting. And have you looked at or are thinking of looking at other language combinations? I'm wondering if something like Japanese and English, where the fundamental structures of the language and the concepts behind them are even more different, might require an even greater amount of self-control or inhibition. Any thoughts?
That's a good question, but whether there might be differences, say not only a language difference, but an orthography difference as well, whether that might foster more flexibility. We don't have the answer to that specifically, but some previous research suggests that the effect occurs across many different language combinations. So including Chinese, English. We can't say yet whether the effect is stronger in, say, an Asian language versus English compared to the Spanish English.
Okay.
That's a good question.
Okay, we have a question over here.
Yes, in the less is more task, given the pattern that you found where the less resembling the symbols were of the actual objects, the better the performance was, is it possible that you would get even better performance with purely arbitrary symbols?
We've thought about whether purely arbitrary symbols would produce even better performance. That's a good question. And of course, what we don't show you are all the pilot things that we try, all the things that we try. And at one point, we thought, okay, we're going to give them, because we're psychologists, we'll give them a psi symbol, right? And that'll represent more, and we'll give them an omega, and that'll represent less. What happens with 3-year-olds in that case is the working memory requirements become so overburdensome that they can't retain the link. So it's really critical that children retain the link between the symbol and the referent for this to work. And in fact, our researcher couldn't keep it straight. Which one represented more and less? So that's a good question. Abstract symbols help, but only up to a point. If it becomes too abstract, other information processing problems start to interfere.
Well, thank you again.